Hi, my name is Maddie Matthews, and this is my Physics 2212 Lab 1 report on charged tape. So first, to start, a quick introduction. So the purpose of this lab is to investigate the interactions between charged pieces of Scotch tape and then to determine the amount of excess charge on one piece of tape. And we did so by calculating the observed charge of each tape using measurements and fundamental physics equations, and then we also used GlowScript to code a computational model that simulates and calculates these values as well. So what we used for this lab was GlowScript to do the computational model, and then we also used Scotch tape, a ruler, a tabletop to charge the tape on, which I'll explain later, and then two identical objects to support the floating tape in the second part. And for my group, we used the stools that were in the lab room. And a brief overview of our results is that the charge on each tape we found to be 1.167 times 10 to the negative 8th, and then the number of electrons lost by each tape was 7 times 10 to the 10th. So some fundamental physics concepts at play here are Newton's second law, which describes the relationship between momentum and net force applied to a system, as you can see down here. So like the net force equals mass times acceleration. And then gravitational forces were also at play, and that describes the attractive force between two objects, as you can see in the bottom right of the equations. And then lastly is a new one, which is Coulomb's law, which describes the force between two electric charges following the equation that you can see on the top right. So a brief overview of our initial conditions is we found the mass, length, width, and then area of the tape that we were using. And then from there, we also could calculate the number of atoms by dividing the tape area by atom area. So if you look on the figure 2 on the left from the lab instructions, basically what we would do is put one piece of tape over a base tape and pull it off to give it that electrical charge. And then the first thing we did was hang it from the table to see how it would interact with the hand. So then for the actual setup for the floating tape, we found our system to be tape B and the surroundings to be tape A and everything else. And then if we play this video up here, you can see how the charged tape was making the tape float between the two stools that we used. So we measured that distance between the two tapes, distance D, and found it to be 2.5 centimeters or 0.025 meters. And then there's just a brief overview of like the actual setup, since the video is a little unclear. And then from there, we were able to draw out our force body diagram and do some calculations. So we used the mass times gravity to find the gravitational force, and then from there found the electric force. And then from there, we were able to use Coulomb's law to find Q and then calculate the number of electrons lost. Then we went over to GlowScript and coded a little computational model of this situation. So similar to the force body diagram in the last slide, you can see over on the right what that would look like from our code. So we have the little blue ball, which is representing the tape, and then the force up and the force down. So showing you the electric force and the gravitational force. And then you can also see the charge of the piece of tape, which we found to be 1.16 e to the negative 8, and then also the number of electrons lost, 7.2 times e to the 10th. And then we also found the electric field and then the electric force using those, which is similar to what we calculated before. So assumptions that we made are that we had to ignore air resistance and friction and assume that they're negligible in this situation. We also treated each long piece of tape as a point charge with the charge concentrated in the center of the tape rather than like the entire long piece of tape. And we also assumed that each piece of U tape we made had the same amount of evenly distributed charge across it. And some possible sources of error related to this are there was unequal distribution of charges on each U tape, and also handling the U tape to like hold it up to the floating tape could mess up the charges, which I'll explain a little bit later. And then also just some human error from measurements because it was hard to measure the floating tape with it on the stools. So discussion questions. What if electrons had positive charge and protons have negative charge? What would change about this experiment? And the answer is nothing would change because both of the tapes would be negative instead of positive, so they would still both repel each other. And going back to what I was saying before, it's important to handle the charged tapes as little as possible because when they come into contact with your hands or other objects, they try to gain back their lost electrons and then will begin to neutralize and charge. So thank you.